Hello everyone and welcome back to another video. Today will be the first of many videos which goes over a chess engine which basically plays the game of chess for us. So over here is basically the screen, and then if we were to play a few moves with the white pieces, we can see that the bot is responding with certain moves. So when we played e4, the bot played knight c3, and then now it plays knight f6, and so on. So this is basically the project which we will be going over how to do. The bot is basically just playing the game of chess. And now let's have a quick look at the overall mind map of our general plan of how to create this chess bot. So there are 5 main modules involved in our creation of this. There are the foundation modules, which basically have certain key foundational properties of the functions which will be used throughout all the other modules. So a notable example of this is the Fen notation for chess. So I'll quickly explain what the Fen notations are. So a Fen string is basically a string of all the different pieces on the board. It's a very compact way of representing a certain chess position, and it represents every chess position uniquely. And this is a much more convenient notation than, for example, a 8 by 8 array of numbers, and with each of the numbers representing a string, representing a piece. It's a much more compact way of representing it. So we need some sort of function which goes from a Fen string and then it stores it and then converts it into the internal representation of a computer. And then another example is we have output, so it just outputs the board. So those are a few examples of the foundation modules, but and now another important group of modules is the display and interface side of things. So this is basically the user interface side of the chess engine. So what it does is it displays a move after it's been played, and it displays the counter move played by the engine as well. And then that's the display side. Then we have the legal move functions. It's probably the most important group of functions. It determines which moves are actually legal to play in a certain position. So if you're familiar with the game of chess, then you'll know that there are a handful of moves which we can make with each of the pieces. However, not all of them are actually legal. So, for example, if a move, if you're in check, you can't just move another piece, which prevents the check. So things like that and several other considerations which we'll need. For example, castling, pawn moves, like en passant and stuff. We need to take all of that into consideration within this legal moves function. And now we have the engine evaluation. So this is the core brain of the actual engine, in which it determines which one of the legal moves is actually the best one to play in a certain position. Since in any given position there are usually between 50 and 200 moves to actually play, but then only one of them will be the best move to play. So it basically looks into the future, if you like, by evaluating if it plays a certain move, what will the opponent play to that move, and then what will the bot play to the opponent's response to their move, etc., etc. And it will do all of that to determine what the best possible move in a position is. And then there are the core functions. So what this does is this just draws all the other functions in all of the other modules together, and it basically decides one of them is the play function, for example, which it's basically just a logical sequence in which all these other functions are carried out. So for example, it would take the user input of the move which the human player played, and then it would pass it to the AI player. The AI player would then generate the legal moves for that particular move. Then it would evaluate all those moves using the engine evaluation, and then it would finally play an output move, which it would then need to display back to the interface, and then the cycle continues. So that was a high-level overview of the different modules. Let's have a quick look at the actual program. Now, I won't actually go over all of these modules in this video, but in all the upcoming videos, we'll look at each and every one of these in great depth. But if you would like to check out these modules, feel free to check out my GitHub, and the link is provided in the description below. So yeah, as mentioned earlier, we have the foundation functions over here, then the legal move functions, and then the UI functions, and then the evaluation functions, and then the core functions. And one more important thing which I'll mention in this video is the fen notation. So I've provided a brief description of what it is, but I haven't explained how it works. So how it works is basically, for each of the different pieces, it's represented a lowercase character for black pieces and uppercase for white pieces, and then the starting character is like pretty typical chess like notation stuff. So it's just the first letter of whatever piece it is: rook, bishop, queen, rook, etc. Except king and knight both start with K, but then knight is represented with an N instead. So that's how we do it. And then if there are basically gaps inside the position, we represent that with a number, saying how many gaps are after a certain piece. And then we do that for each and every row inside there. And that's basically that's how we represent the fen strings. And then we finally call the play function. And as mentioned earlier, what the play function does, it just it takes in all the other functions and then outputs the moves. So yeah, I showed a quick demo of how it works, but maybe we can continue a few more moves to see if maybe if we play d4. Then if you notice the bot is thinking for a few seconds each move, we can obviously change the depth, and then that would influence how long it takes to think. But it is playing pretty reasonably, like for the amount of processing power which I've given it. So yeah, that's pretty much just a quick intro to how the bot works, and like a quick intro to the future upcoming videos, which will explain in detail how exactly you can code an engine exactly like this one. So I'll see you in the next video. Thanks for watching. Bye.